This program has been designed mainly for recorded use. Full details are in the notes for teachers. When a coin is tossed, what is the probability of getting a head? You could find out by repeated experiments. We tossed a coin 100 times, and our results looked like this. After 100 tosses, the proportion of heads settled down to a value of about 0.55. Just over half the tosses were heads. You could use this to estimate the probability of heads as 0.55. But are 100 experiments enough? Here's a different approach to probability. For a coin, there are only two possible outcomes, heads or tails. There's nothing in the look of a coin to suggest that one is more likely than the other. Our intuition tells us that the two outcomes are equally likely. So we would expect that in the long run, about half the tosses would produce heads. So just by looking at the coin, we can assign a probability for heads of 1/2. Similarly, a die has 6 faces, each of them equally likely to turn up. So we can assign a probability for any one number on top as 1/6. Now suppose we roll 2 dice. What's the probability of obtaining, say, 2 6s when we roll them? Let's have a look at all the possible outcomes. With this white die showing 1, the black one could be 1, or 2, or 3, or 4, or 5, or 6. Similarly, if the white die shows 2, there are 6 possibilities for the black. And so on. Altogether, there are 36 possible outcomes. The result we're looking for, 2 6s, appears just once. How do we express the probability numerically? We assume that there's the same chance of any of the 36 outcomes occurring. They're all equally likely. So the probability of 2 6s is 1/36, or 0.028. Now, what's the probability of getting, say, a 3 and a 5 together? For that, there are 2 acceptable outcomes, 3 on the white die and 5 on the black, or the other way around, 5 on the white and 3 on the black. So the probability of 3 and 5 is 2 in 36, or 0.056. Here's something to think about afterwards. What would be the probability of getting a total of 6? Roulette is a game of chance. Each number is equally likely to come up. Winning literally depends on the roll of the ball. So what is the probability of winning on a single number? There are 37 numbers, 0 to 36. So the probability of any one number coming up, say 13, is 1/37, or 0.027.
Oh, you mean my shirt?
But there are 36 losing numbers. So the probability of losing a single number such as 13 is 36/37, or 0.973. You can improve your chance of winning. Putting a chip here indicates that you're betting on one of the numbers 1 to 12 coming.
£30.
Now the probability of winning is 12/37, or 0.324.
£100.
This means you're betting on an odd number coming up.
10% of £50.
Probability of winning on an
50
odd
is a
number is 18/37, or
So
0.486.
10% of 50 must be
The probability of winning at roulette depends on the number of outcomes you bet on.
It's a
Do you own any premium bonds?
10%.
What is the probability of one of them winning a
10%
prize?
means 10 in every 100.
Yeah,
Well,
but
here's Ernie,
what's
the machine
spread
that
out
makes the
the-
draw. Some people think that Ernie favours some prefix letters more than others, or that it
Yeah.
favours the south of England.
10.
In the month we filmed, there were 1,344 million bonds eligible.
I know that.
Each one could win the top prize of £100,000 in the monthly draw. Did each bond have the same
10%
probability of being
each
picked?
pennies is
Yes, because that's what Ernie is designed to do.
10.
Ernie is not a computer. It's not been programmed.
Right. 20.
Ernie
10 for
generates the
100.
numbers from the haphazard movement of electrons in one of its circuits.
10.
It's impossible to interfere with the electrons.
10 times.
The electrons and the draw are completely random. Every number has the same chance of being picked. So as there are 1,344 million bonds, each
10%
with the
of
same chance of coming up, the probability of a particular bond winning the top prize in the monthly
10% of
draw
20
is
cornflakes
1 in
is 20.
1,344 million, or about 0.0000.
Only you won't buy much
Not,
meat, but
not,
20.
not,
Let's see what
7.
the last job was.
The probability of a
Cost of
particular bond
materials,
winning some sort of prize is better than
What's
this.
10% of £35?
Altogether,
I think-
there are
What?
122,000 prizes of different values each month. So the probability of a particular bond winning any one of these is 122,000 in 1,344 million, or 0.00091. If you have the maximum holding, that's 3,000 bonds, the probability of winning is even better, 3,000 times better. It comes to about 0.273, just over a quarter. Incidentally, that's why you often see the prefix Z in the winner's list. There are more bonds with Z because if you buy bonds in a block of 500, each bond has a Z prefix. Probabilities are numerical expressions of what we expect to happen in the future. Things that have a low probability are unlikely to happen. Things with a higher probability are more likely to happen. Probabilities can be compared on a scale. But what are the limits of the scale? Well, at the top of the scale, we put things that we expect will always happen, because they've always happened in the past. For instance, the probability of the sun rising tomorrow is given the value of 1, because it's a certainty. At the bottom, we put things that can't happen, or that we expect will never happen, because they've never happened in the past, like scoring 1 million goals in one football match. That's impossible, so it's given a value of 0. All probabilities are somewhere between impossibility and certainty, so all the values fall on between 0 and 1 on the scale.
There you are.
Weather forecasters have the job of
You said you
predicting
were going to
the
make it
future.
worth my while. I don't
This
like
is
the
the
way
United Kingdom Meteorological Office in Bradford.
Chicken, are you?
Are you listening to me?
Oh,
Here,
sorry.
the forecasters receive data from a worldwide network of satellites and weather stations.
Tell you in the morning. You leave me if you like. Right.
The data is translated into weather maps and analyzed by the forecasters. A computer program helps to show how the weather might change over the next 24 hours. But despite their vast skill and experience, and the help of the computer, forecasters feel that the accuracy of the probability assessments is such that words are a better description of the uncertainties. For instance, here is the weather forecast for the United Kingdom. Today, snow is expected over most of the country, and it's unlikely that temperatures will rise much above 5 degrees C. There's a possibility of some brief sunny periods. Fog patches are probable this evening. But what do the words mean? We made a list of terms commonly used to express probability and arranged them in this order. However, the different words mean different things to different people. When someone assigns a numerical probability, then we know what they mean, even if we don't agree with them.
Just finishing off his
3 white balls, 4 red balls, and 5 black balls, a total of 12 balls. Picking out one ball at random, what is the probability that it will be white or red? 12 possible outcomes, all equally likely. In 7 cases, the outcome will be white or red. So the probability is 7 over 12. But now look at the same question in another way. The probability of drawing out a white ball is 3 over 12. The probability of drawing a red ball is 4 over 12. The sum of these two fractions is 7 over 12. And as we've already seen, that's the probability of drawing either a white or a red ball. So the probability of the ball being white or red is the sum of the separate probabilities for white and for red. But can we always add probabilities like this? Suppose you wanted the probability of seeing a 5 on either one of these two dice when you roll them together. You might say that the probability of a 5 on the white die was 1 over 6, and you'd be right. For the black die, it's also 1 over 6. If you add these two probabilities together, you get 2 over 6, or 1/3. But that's the wrong answer to your problem. Out of the 36 possible outcomes, there are 6 when the white die shows 5. And there are 6 outcomes when the black die shows 5. 6 out of 36. But there's an overlap. 5 on the white and 5 on the black. There aren't 12 possible outcomes, only 11. The probability of seeing at least one 5 when you roll 2 dice is 11 over 36. When you've got an overlap, you can't add the two separate probabilities. In the case of the colored balls, the ball you draw from the bag can't be both white and red. There's no overlap, so you can add the separate probabilities. But there's another way of looking at this probability. The probability of white or red is 7 over 12. The probability of drawing a black ball is 5 over 12. What happens if you add these two probabilities? 12/12ths, or just 1. A probability of 1 means certainty. If you draw out a ball, it must be black or white or red. That is, black or not black. So if you know the probability of a particular outcome, say black, then if you subtract that probability from 1, you get the probability of all the other outcomes. The probability of black is 5 over 12, so the probability of not black is 7 over 12. No overlap. The ball must be either black or not black, and no other possibilities. But what is the probability of getting, say, a 4 on the white die and a 4 on the black die? That only occurs once in the 36 possible outcomes. So the probability is 1 over 36.
Oh, morning, Grandad.
This probability can also be obtained without having to analyze all the outcomes. The white die can be either a 4 or not a 4. The probability of a 4 is 1 over 6. So the probability of not 4 is 1 minus 1 over 6. That's 5 over 6.
10% of
Whichever it is, there are 2 possibilities for the black die, with corresponding probabilities. To get a white 4 and then a black 4, we go down the bottom path in our diagram. We've already seen that the probability of getting a white 4 and a black 4 is 1 over 36. And this is the product of the 2 separate probabilities. 1 over 6 times 1 over 6. Aircraft safety is of prime importance to the builders, operators, and of course, the passengers. In something as complex as an aircraft, safety depends on the correct functioning of a large number of systems, each with many components. A modern aircraft can have literally miles of electric cables and hydraulic pipes. However, because planes are so complex, things do still go wrong. As an example, we looked at the probability of failure of just one of these systems, the landing gear.
How about £13.50.
To operate
my
correctly,
breakfast, you
the
mind?
landing gear needs both electrical and hydraulic power.
£13.50.
Let's look first
Right.
at the electrical system.
1300 pence. 10%
Each
of that.
channel is made up of the plane's engine, which drives a gearbox, which drives a generator, which supplies electrical power to the wires,
5
controls, and so on.
100 and
Reliability data for all components, collected from tests or actual in-service experience, has shown the probability of failure for each of the components per hour of flying time.
40.
Because the components are in series, the channel will fail if component 1
To get
or
10%,
2
you divide by
or
10, right?
3
So that the
or
figure
4
never changes.
fails.
You just move them along one place.
There's no overlap because
Well,
as soon as one
1.4.
component has failed, the system fails.
1.4.
So the probability of the system
I'll take your
failing
word
is
for
the
it.
sum of the individual probabilities of failure.
£8.
Because for this example, a failure probability of over 1 in 1,000 is considered by the manufacturers to be much too
That's
high,
no pound.
they build in a second channel in parallel with the first.
80 pence.
This second channel has the same probability of
Simple,
failure.
this is.
But now, the electrical system as a whole will only fail if both the first and the second channels fail. So now, the probability of both channels failing is the product of the probabilities of each channel failing,
Move the figures
rather
along.
less than 2 in a million.
£5.
But the electrical
They don't
system
cost
is
that
only
much.
part of the story.
The cost of the
Correct functioning of the landing gear also depends on the hydraulic system.
Oh.
The electrical system provides power for a hydraulic pump, which pumps the hydraulic fluid under pressure to the operating valves. Let's start with the left-hand end of this series.
Charge the customer.
Wood.
The probability
£9
of failing to pump is the
and
sum
90
of the
pence.
individual failure probabilities.
£11. 1.
In parallel with this electrical pumping system, an engine is made to drive a hydraulic pump directly. Now, pumping would only fail if both these channels fail. The product rule. A very small probability. The system can also fail as a result of the loss of hydraulic fluid or control valve failure. And so, the overall probability of failing is the sum of these individual probabilities. The probability of pumping failure is so small compared with the last two that it can be ignored. Even though this probability is less than 1 in 20,000, it's still too large for the aircraft designer. But he has one more trick up his sleeve. A free fall system where the landing gear extends under gravity. This backup system acts in parallel with the electrical hydraulic system, and so the total probability of failure is the product, less than 1 in 10 million.
Well, your line's got sense. Yeah.
It's safer to take a trip in this plane than it is to cross the street.
Oh, that. Right. £35. Right. £3.50. Let's go together.